This is the this is the replication manager interface. So here, what I'm going to do is like clean all this cluster. So I'm going to send some instruction to clean up this cluster, and I'm going to reprovision the cluster on OpenSVC to see how easy it is with OpenSVC or like Kubernetes to just create HA clusters. So now you see the servers, they become failed. What happened is Replication Manager tries to a certain number of times to detect the failure, three times, 5 times, then he already thinks the thing is dead. So now I'm going to recreate this cluster from scratch. So here, so this cluster is defined. You can define the cluster dynamically by adding monitor. You can add a MariaDB monitor, Percona monitor, some proxy SQL or whatever. And here I'm going to send the provisioning on all those monitors. And what Replication Manager will do is contact the OpenSVC, create a configuration file for my service. Here we can see is doing that with the OpenSVC API and start provisioning some services. The services is, for me, a collection of file system, which we call the pod. In Kubernetes as well, it's a pod. It's an IP address to join the service. And maybe if there is multiple Docker images, you can have multiple IP address. Cron tabs or jobs, a lot of things, all packed together in one single unit. And this unit can then, thanks to the orchestration of OpenSVC, can fail over, can scale. If it's a web service, for example, you can scale out, things like this. So you see all happening in real life. At some point, he will create the replication on the nodes. Okay, standalone means no connection. And now Replication Manager detected the master and the slaves. So he has provisioned all this. And you can see the current GTID. So there's no traffic yet to my cluster. You can add some traffic. You should see in a few minutes or in a few seconds the GTID moving now. So sending the traffic to the master database. Here I have provisioned some proxies. So you have like 2 proxy SQL running. It could be Maxscale, HAProxy, whatever. Replication Manager will help the proxies to discover who is the master, who is the leader. And those proxies can be consumed and everything, so I will talk later with the slides. But you can see the tool working, and the goal of Replication Manager is to do things like switch over. And then you will see that the master will become slave, and the traffic will be routed to the new master. So this is by default. By default, we don't fail over automatically. We fail over manually. So we send you an alert. Okay, the master has died. Yes, I'm simulating this with OpenSVC. I'm asking OpenSVC to stop the master physically. So when I'm doing that, the master becomes suspect. He's trying to see false positive stuff. So what is a false positive? It doesn't ping for 5 times. Then those slaves here also are in error. They cannot talk to the master as well, which is important. Because otherwise, if one slave can talk to the master, or a proxy can talk to the master, it means the master is not really dead. I think he's dead. Or Replication Manager thinks he's dead, but maybe it's me having a problem, not the master. And you see, so it's not automatic. You click on failover to continue the process. So here you should have received an email telling you there is a problem. Okay, so now there is a master, and you can restart the old master, and he will rejoin the cluster with using different techniques. And you can choose the techniques to rejoin. It could be a snapshot, it could be a backup, it could be that he has no lost any event. Okay, so here, for example, there is an issue because it's rejoined as standalone server, so it means that he cannot rejoin the cluster because the master was ahead of the new master. So you have to set up some settings to make him rejoin differently. So he can rejoin by, for example, taking a backup or restoring a backup. Okay, so that's the goal of the product. I will switch to the slides to show you a little bit of Replication Manager, and then we will see what happens with OpenSVC. One last thing, all those services I have deployed are deployed in Docker, thanks to OpenSVC, and they are deployed on 2 OVH nodes, which are the 2 nodes running OpenSVC. Or you can have 3, 4, 5, whatever. But they work as a physical cluster, and all the databases, the proxies, and everything are Docker images, but it could be anything with OpenSVC. It could be LXC, VMware, or whatever. Yeah, so let's really start the presentation. Okay, so the idea of Replication Manager, it's a state machine, it's an event scheduler, it's a monitoring system, it's a croner system, you can clone things. It manages failover, and it's multi-topology, multi-root. Here is the different route you can use. It can parameter consul, proxy SQL, HA proxy, maxscale, vitess, whatever. Shard proxy is our own technology based on Spider. We will demo that tomorrow. And multiple clients, so it's a client-server architecture. You have a REST API, JWT REST API, and you can drive all what I've done with the HTTP clients, or by command line clients, or by HTTP API, or the web interface. And what Signal 18 is the company we created to support the product, and OpenSVC, is our orchestrator. So it orchestrates a lot of things like Docker, KVM, Zone, LXC. It's cross-platform. It monitors the infrastructure. It does the configuration like Valgrant or Puppet for you. And it's service-based failover and placement and scalability. Then for the proxy, we have all this. So I move fast. Fast false positive detection. Okay, so to change in configuration file from manual to automatic, you can set up in configuration file this parameter. We do a lot of things during failover. So the best practice are applied here, like in MHA or Orchestrator, which are the same type of product. So we do really the best things, like trying to flush table with read lock, first without read locks to see if there is long running transaction, things like this. Yeah, so different type of checks and things like this. Minimum setting is very easy. You give your database server, and then you give the user for connecting to the database and user for setting the replication. And you go. You're good to go. The auto-rejoin stuff and the monitoring stuff push to some Graphite storage. And then from the Graphite, you can put Grafana on top of it. And then we push all the metrics. So thanks for Replication Manager. Now we'll go more specifically into OpenSVC. And I will give the hand to Arnaud, which is OpenSVC guru. Thanks.
okay? Tu m'entends? Okay. So let's talk about OpenSVC after Stephane's introduction to Replication-Manager. We will have a look on how it works undercover. So as Stephane said, it's based on OpenSVC tool. OpenSVC was founded in 10 years ago now, and is something between old legacy clustering solution and Kubernetes Mesos container orchestration solutions of today. The main idea we work on since for 10 years now is building services and packing inside services resources like IPs, file system, disks, containers, replication, remote, local, to bring something global that show you what is needed on your production to make an application works fine and deliver the service. So we support multiple service topologies, classical active-passive, active-active, as named as Flex, and scalar services, which means we can scale up and scale down dynamically those kind of services. Unified command line, what does this mean is that you build services on top of different technology, like Docker, like LXC, like Solaris Zone or whatever, and you have a command set for all of those technologies, which is convenient when you have to delegate the simplest tasks to lower skilled people. There's a system for templating, of course, and doing stuff industrially. What's interesting also, so I didn't say that, it's the Python stack you deploy on servers. And that's all you need to build clusters and deploy services. And here we have an optional stack that makes sense when you have lots of services, lots of servers, to concentrate all the information in this web portal, which also provide the REST API of the overall solution. Let's move to the next slide. So here is the drawing of Stephane implementation for Replication-Manager. So what we can see, at the bottom we have two nodes. So they are at the OVH cloud provider in France. It's on-premise nodes, physical, real. We have local disks, so Linux OS, and all the disks are configured with the ZFS. So as you can see, IPs are in different subnets. On top of those two servers, we deploy this stack, which is CNI and Weave. So CNI is a runtime to provide a container networking interface, which is specification on one side and libraries that provide that. And Weave is a plugin. Multiple plugins exist, but Weave is one of them that rely on libraries and is able to provide software-defined network across extended cluster. It's the current setup for Stephane. So we are able to provide this extended VXLAN between the two nodes, purely private IP addressing. On top of this, we install OpenSVC cluster. So after you install OpenSVC, you have 3 commands, and you have joined both nodes. It's quite easy. And in the blue part, on the top of the slide, we have services, OpenSVC services deployed in the cluster to be able to make Replication-Manager do the job. So we have core services, 4 services that we will talk about in the slide just after. we have two services managing Replication-Manager. So the interface Stephane was just used is served by those services, production one and DR1. So we are still on the infrastructure services. And on the top, we have the MariaDB and the HAProxy, real application server for the demonstration database. Okay, for the overall picture. So, little explanation. So what I didn't talk about, it's okay. So the core infrastructure services, we have 4 services. We have a DNS internal to the cluster to be able to have a name resolution service for the cluster. We have Weave for the IP. When you bring a new container, it gets a private IP to be able to discuss with it. You have an ingress gateway. Discuss a little bit about that later. The role of the ingress gateway to, on one side, bring the public IP, and on the other side, be able to route traffic from customer to the real container in the backend. And we, of course, have the OpenSVC collector for the REST API and all the stuff. Oh, another detail. All this stuff are Docker containers. So about name service. So how it works. As you saw, we deployed a VXLAN extended over 2 physical nodes in a private subnet. So we need to be able to contact all the containers that can be spawned and destroyed and so on. So the solution we use is, as a Docker containers, we bring Power DNS containers, servers, and recursor. In OpenSVC, we feed through a Unix socket. We feed the Power DNS layer with DNS records, A records, and also SRV records to be able to identify which service is running where in the backend of the cluster. Okay. So simple example, we describe in the OpenSVC service configuration file which port we are currently exposing. It allows us to fill in the DNS records accurately. And when the Docker containers are spawned, we automatically configure them to have their DNS resolution layer pointing to the cluster internal DNS servers. That's how we do for private networks. The second problem, which is common to every container orchestrators of today, or like Kubernetes or whatever, how to expose services with a private IP to the external. So we use a product which is called GoBetween, layer cat load balancer. So as I said, you have the public address. And here we have an OpenSVC development, a Docker image, which just poll the DNS configuration and automatically push it to the REST API in GoBetween. So as to tell GoBetween, okay, you can serve this service with this and this and this container. Okay. And as it's a load balancer, he has checkers, and he knows if one is up or is down. That's how we do for routing the traffic. Another keyword to specify in the configuration. When you have a setup like a web server in your OpenSVC service, port 80, you still have in the same service to say, okay, I provide service on port 80, but I want it to be exposed on the public port 8080. It's an example, of course. back to Replication Manager, the overall cinematic which is used, like described by Stephane. So logged in the Replication Manager portal, fill in different information when building a new environment or when you want to deploy a new setup. Replication Manager build internally OpenSVC service template. Tags, we will see later what does this mean. And the template are posted to the OpenSVC collector. After that, Replication Manager triggers template instantiation, which at this time become real services. So provisioning happened, creating file system, mounting file system, plumbing IPs, pulling Docker image, and things like that. That's for the cinematic work all the time. From the CLI, when we use the Replication Manager CLI, this command is used in hidden way by Replication Manager, and it's generate a flat template file that we will discover just after. And with this file, just have one command to create a new MyDB service and provision it on the fly. All those tasks are doing by automation with RM, Replication Manager. Let's have a look on how is an OpenSVC service configuration file in the current setup, which is MariaDB with Replication Manager. So it's just a flat file, very simple. Default section, we won't describe every field, but this one, for example, nodes, the list of node name where you want your service to be able to run. If you build a 10 nodes cluster and you want only 4 nodes for one service, you can list here the nodes. Different service topology. If you recall active-active, active-passive, it's here that you say that. Different setup for Docker stuff. We're able to use the Docker daemon from the system. Or we also have customers that want multiple Docker daemons on the same system when they want to host like multiple developers on the same host, and everyone have its own Docker work area. We can do that this way. And we have reference in green, which point to a specific section in the file. We'll see that in the last slide. An application code. When you consider whole production with a lot of services, this code allows us to know which service belongs to which business entity in the production. So it's the same file. We have file systems, so it's quite classical. What kind of file system? Here is ZFS, which pool, which data set in the pool, the side for the provisioning purpose. And here we have another file system and specific mount options. Please note this line, which is a hook that we trigger in post-provisioning of the file system. I will get back on it later. So, simple file systems only. Here we declare the IP address. So for Stephane purpose, Stephane usage, only one is needed. So tags are not really important. What we say here is we want to use a CNI IP. Where do we want to plumb the IP? In the Docker container that on this name. And we want the IP to be get from the network named Repman, Replication Manager. It's how we name the CNI implementation on this cluster. So very simple. Here we describe Docker containers. So nothing very interesting. If you already played with Docker, you're familiar with that. Variables, image name, thing like that. Okay. Yeah, you're right. Yeah. So Stephane is right. When we build the IP in the previous slide, we attach it to the first container. And in the second container, we explicitly say get your network namespace from the first container. So we have this one which holds the network stack and the other which only holds the application stack. We separate the role. Here is a specific object in the service, which is a task. You have a schedule for this task, every hour, every minute, like you want. And you do something. You run a script. Here we trigger the database jobs that are get from Replication-Manager. Why is this very useful? Everywhere I went at customer side, always people say we have cron tabs that are okay in production, but they are never okay on backups or DRP servers. Using that kind of stuff, you're always sure that your cron jobs are attached with the service and they follow the service wherever you put it in your production. The mobility is no more a problem. Last section of the service file is a kind of keyvalue store for the service variables. It remained 4 or 5 slides maybe. With the OpenSVC solution, you have a feature that is like Puppet, like Chef, all this kind of software to ensure configuration are correctly applied. Like other tools, we set up targets in the collector. We want this parameter, we want this, we want this. We put conditions. We can put many conditions that we have in the collector database. We say this parameter on server that are on Linux system with more than 4 CPUs, as an example. And we also have tags. If you recall, we discussed about tags, and it is the way Replication-Manager tune the DB system. When you make choice for option, configuration option in the interface, you have Replication-Manager tagging the service with specific configuration option. And those options triggers configuration file in the MariaDB implementation. SQL mode Oracle, like this one. SQL mode Oracle. So here we say, if we want SQL mode Oracle, we deploy a CNF file with this parameter, a specific UID, GID, and the content should be this piece of file. And this rule is only shown to the service if the tag is put by Replication-Manager. That's why we have many configuration parameters, and you just have to pick them, and they are automatically applied. That's how, just after file system provisioning, I showed you previously, you have a hook post-provision. It triggers this piece of configuration to deploy all the configuration files for the MariaDB to operate correctly. To avoid secrets hidden in file, clear text passwords, and so on, we have a keyvalue, a secret vaulting system in the collector. We can push any keyvalue, strings, binary, anything else, either through interface or through REST API. We plugged in a hidden and automated Git tracking, which is very useful to to see what has changed. That's OK for the vaulting. And here is the result. We are logged on one of the both nodes on the cluster, and we call the command service monitor. We have 3 parts. On top, the multiple threads for the cluster for operating correctly. Here we have a system score when you use a specific placement algorithm for the services to be able to fail over to multiple nodes. And here the most interesting part is the list of services which are currently running on my cluster. So we found the 4 infrastructure services, and here all the DB implemented by Replication-Manager. Here we have states. As an example, this service is up on node C1 and N1 and is frozen at the moment. So it's very convenient when you have a cluster, multiple services, to have an overall view of what is running at the moment on my system, what is up on my system, what happens if I shut down this system. And here is another set of commands that allow you to describe service by service what is currently up or down. So print status. The first service is a DB. So if you recall the configuration file, the flat file, we find for each resource what is the current state at the moment. So the IP is up in the Repman CNI network with this IP. The 2 file systems are up, and the containers also are Docker here, and you have the image and Docker container aliases. So it's very useful to have a global view of your service if everything is fine or not. Here is the sample DNS service with the Power DNS image. Same thing with Docker, very simple. So print status command, this one, print config to display the overall file, and the simple config to stop, start, take over, give back, failover a service. That's where, when you implement either Docker or LXC or KVM or whatever you want, you do not need to be an expert in KVM to failover a KVM. Just use this command and everything will be done automatically. But on the command line, you still have all the real, actual commands that are displayed. So nothing is hidden. And to manage resource by resource, you can also specify a RID for resource ID, just to stop one component and start it later. That's all for this presentation. If you want to have more information, we have a sympathetic screencast on our website, 20 minutes, and you see the overall from the very beginning, simple standalone node with 1 service to a global cluster with DNS, CNI setup, such as this one. Thanks for your attention.